Welcome to lesson 7.7, solve right triangles for geometry. So the idea and basically the meaning of solving a right triangle is to find all the missing sides and angles. So in order to do this, we need one of two scenarios. First, we either need to know two of the side lengths, or we need to know one side length and the measure of one acute angle. If we have either of those scenarios, we can completely solve a right triangle. So there are a couple additional ratios that we're going to use. These really are nothing new compared to the tangent, sine, and cosine. These are known as the inverse ratios, and in order to do these, you will need to have a scientific calculator, not necessarily graphing, but scientific, or you can always just Google scientific calculator and one will pop up with these buttons on it. So what we want to keep in mind before we look at the inverse trigonometric ratios is we want to keep in mind that the tangent is always the opposite over the adjacent. The sine is always opposite over hypotenuse, and cosine is always adjacent over hypotenuse. So our first inverse ratio is the inverse tangent. So if we're looking at triangle, the right triangle ABC here, and we know A is an acute angle, then the tangent of A, let's say, is x. So the inverse tangent, written as tangent to the -1, inverse tangent. So if you ever see the tangent, the sine, or the cosine to the -1, that's the symbol for inverse. So the inverse tangent of x is the measure of angle A. What that means is if we know the tangent, opposite over adjacent, so in this case BC over AC, to figure out the measure of angle A, you would type into your calculator the inverse tangent of whatever BC over AC is. And we'll see some examples of that. But simply put, if you know the tangent, the inverse tangent of that number will give you the angle measure. So in this case, the inverse sine, if the sine of A is y, then the inverse sine of y is the measure of angle A. So if the sine of A was 0.4, then you would type into your calculator inverse sine of 0.4, and that would give you the measure of angle A. If the cosine of A was the letter Z, then the inverse cosine of Z will give us the measure of angle A. So again, if we knew the cosine, let's say it was 0.75, then you'd type into your calculator inverse cosine of 0.75, and that would give you the measure of angle A. So example of that, we will look at example 1 here. Use a calculator to approximate the measure of angle A to the nearest tenth of a degree. So looking at this triangle, we were given side BC and side AB. So if we're looking at angle A here, we were given the opposite side and the adjacent side. So if I have opposite and adjacent, I'm going to use tangent. So the tangent of angle A is 15 over 20, which is 3/4 or 0.75. So what you would want to do to figure out the measure of angle A, we need to use a calculator. And what you would put in is the inverse tangent of 0.75. That would give us the measure of angle A being approximately 36.9 degrees. And again, this button on your calculator should be, if on most calculators you have to hit the second button and then they are located above the tangent, sine, and cosine button. So a couple more examples. Let angle A and angle B be acute angles in right triangles. Use a calculator to approximate the measures of angle A and B to the nearest tenth of a degree. So angle A, they told us the sine of A was 0.87. So if we want the measure of angle A, we would type in the inverse sine of 0.87, and we'd get the measure of angle A is approximately 60.5 degrees. For B, the measure angle B would be the inverse cosine of 0.15 because the cosine of B was 0.15. So we'll use the inverse cosine, and that gives us 81.4 degrees. Now, example 3 asks us to solve the right triangle round decimal answers to the nearest tenth. So if we want to solve right triangles, first we want to identify what they gave us and what we know. So in this case, they gave us a right angle here at C, an acute angle, 42 degrees for A, and one side. So I was given a side and an acute angle. So yes, I can solve this triangle. And then we want to write down what we know. We knew side AC was 70 feet, angle A was 42 degrees, and obviously angle C being 90 degrees, or a right angle. So first we can find angle B, because all triangles add to 180 degrees. So if we know angles A and C, 180 minus A plus C would give us B. So 180 minus the 42 plus 90 would leave us with angle B being 48 degrees. Then we can use our tangent ratio to find BC. The reason we are using tangent is we knew the 42 degrees, we knew the adjacent side is 70, and BC is that opposite side. So if we are using opposite and adjacent, we will use tangent. So the tangent of 42 degrees would be side BC over 70. So in order to solve for BC, we'd multiply by 70. So BC is 70 times the tangent of 42, which means BC is approximately 63 feet. Then we'd want to use the cosine ratio to find AB. Using cosine because, again, we knew 42 degrees, we knew 70 on the adjacent, and we're looking for hypotenuse. So if we have adjacent and hypotenuse, we will use cosine. So the cosine of 42 degrees equals our adjacent over the hypotenuse, 70 over AB. So when we rearrange to solve for AB, we'd end up multiplying both sides by AB, then dividing by the cosine of 42. So AB is 70 over the cosine of 42. So AB is approximately 94.2 feet. So based on the two angles and one side we knew to start, we now found our third angle and our other two missing sides. Now example 4 is a word problem. So again, I'm looking the first time I read through the word problem for simply what am I given about this scenario. So it says our school is building a new rec stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. A rack, which is the angle of elevation, of 5 degrees or less is generally preferred for the safety and comfort of the actors. Is the rack stage you are building within the range suggested? So if we look at the diagram, which was given to us, we knew the stage was 30 feet long. The rise is 2 feet. and we're assuming they're building it at a 90-degree angle. And then we are looking for that racked angle measure. So in this case, we are given two sides and a right angle. So again, I can find different measurements to solve what I need to. So based on what I was given the side opposite and the hypotenuse compared to angle x. So if I have an opposite and hypotenuse, I will be using the sine. So the sine of x is the opposite over hypotenuse, or 2 over 30, which is approximately 0.0667. So to figure out our measurement of angle x, we would do the inverse sine of 0.0667, which is approximately 3.8 degrees. So the rack angle is approximately 3.8 degrees, which is in our suggested range of under 5 degrees.